Welcome to Old Florida. In recent years, archaeologists have made major prehistoric finds in Florida waters. They're building on a legacy that spans decades, from recreational divers who found fossils and artifacts in Florida rivers, to those pioneers who figured out how to adapt techniques used by archaeologists on land to an entirely different work environment.
This whole field of submerged pre-contact archaeology and submerged landscape study and reconstruction, it's been great to see how far this field has developed, in the past decade and a half.
This is the epicenter of submerged prehistory on the planet. We're definitely in like a renaissance of this work.
What they find here is helping answer questions on a continental scale.
Who were the first Americans? Where did they come from? How did they get here? When did they arrive? And what were their lives like?
Welcome to Old Florida. In recent years, archaeologists have made major prehistoric finds in Florida waters. They're building on a legacy that spans decades, from recreational divers who found fossils and artifacts in Florida rivers, to those pioneers who figured out how to adapt techniques used by archaeologists on land to an entirely different work environment.
This whole field of submerged pre-contact archaeology and submerged landscape study and reconstruction, it's been great to see how far this field has developed, in the past decade and a half.
This is the epicenter of submerged prehistory on the planet. We're definitely in like a renaissance of this work.
What they find here is helping answer questions on a continental scale.
Who were the first Americans? Where did they come from? How did they get here? When did they arrive? And what were their lives like?
We're embarking on an emergency archaeological mission.
Yeah.
We are at the Simpson Flats archaeological site, which is located in Ichetucknee Springs State Park.
What are you looking for exactly?
So I'm trying to relocate the bones that we found earlier.
The site contains in situ remains of a mastodon, and that means it's in place. We have a whole skeleton in place, and it's important to keep it in context.
Recently, areas that had previously been capped by a significant amount of sediment are now eroding out at what appears to be a pretty alarming rate. What we're attempting to do is document as much of this now while we can. It's a situation where the river's going to keep flowing, and it's going to keep eroding from this bank. And so we can either try to learn what we can about this site or know that it's going to be gone forever.
If the bones fall out of the riverbank, they lose part of the story of that mastodon, specifically whether that mastodon had a run-in with humans.
In the 80s, there were Paleo-Indian biface points reported. We've also taken sediment samples from around the mastodon remains and found micro-debitage, so really small bits of stone that were knocked off when somebody was making a tool.
Weird. Some steps you barely sink, and then others you really sink.
To answer big questions like, were humans here with mastodons? Archaeologists have to be precise and methodical in conditions like this.
One of the questions when we get hired was, are you comfortable working in mucky environments? And this is one of those mucky environments.
Working in some of these environments can be a challenge, for sure. There's cold, there's currents. You have to be very flexible, but also very aware of your limits.
That's part of the thing, right? We always joke on the projects that underwater archaeology is a stupid sport because everything is complicated and hard. But it's worth it because the things we can find out about people in the past, there's literally no other way to do it, right?
It's messy, it's frustrating, and sometimes kind of dangerous. But in the last decade or two, underwater archaeologists have been rewriting what we know about people in the Americas.
Mastodons went extinct around the terminal Pleistocene, so like 12,000 years ago. So that's pretty big for people being in Florida that long ago. So, and the Paleo-Indian period extends back past currently 14,500 years with Page-Ladson, which is our oldest site in Florida so far.
Florida's oldest archaeological site is located in an area with unique geology just south of the Osceola River sinks.
Basically, the river comes up and down in a series of sinkholes there, and this is all draining from like South Georgia, North Florida. Half Mile Rise is the longest stretch of the river that's open like this until it heads out to the Gulf.
Page-Ladson is a sinkhole that's about 30 feet deep in the middle, and it's like, I don't know, maybe about 150 feet wide. It's a big circular part of the river.
Page-Ladson is the kind of site archaeologists dream of. It's pre-Clovis.
When I went to graduate school, it was the Clovis first model, and Clovis represented the first people that came to the Americas.
There'd been this idea that the first peoples arrived in the New World around maybe as long as 14,000 years ago, but really just right at the start of Clovis.
And these people made these large lancelet fluted projectile points.
And all of them that have been dated date to right around 13,000 years old.
Clovis dates fit a timeline where people crossed a land bridge from Asia and passed through an ice-free corridor to enter the Americas. If people were here before Clovis, that way would likely have been blocked by a large sheet of ice. Clovis dates fit, and yet archaeologists started finding sites that were older than Clovis.
And this whole paradigm shift is happening of, hey, maybe there's older than Clovis sites that are real. And Mike Waters was talking about how he thought Page-Ladson was maybe one of the most interesting ones of those sites.
Page-Ladson was worthy of investigating further because, you know, back in the day when the Clovis first model was really strong, that a lot of sites that had great potential got pretty much sidelined. And there was work that was done by David Webb and Jim Dunbar.
Basically, nobody thought anybody could do underwater work, same as on land. Well, they developed ways of doing stuff scientifically, stabilize and work a site underwater.
Eddie Green is a retired engineer who volunteered on decades of digs. He designed the dredge system they used to vacuum up sediments. In those days, there was more enthusiasm than funding, and they had to be inventive.
They developed a lot of techniques that everybody uses nowadays to work on underwater sites.
So Jim and Dave went and looked at it, saw that there was some cool stratigraphy at the site, dug some test units, and found that there's a lot of stratigraphy at the site.
Strata are layers of sediments. Think of the Simpson's Flats mastodon. If fossils or artifacts are preserved in a layer of sediment, they are in context.
It's a common refrain in this line of work where you need to have unequivocal artifacts, secure geologic context, and absolute ages of some kind.
Ages are obtained by radiocarbon dating preserved organic material. If artifacts and fossils are in a layer with datable material, then the dates apply to them too.
Having all three of those is the gold standard.
Page-Ladson had well-defined sediment layers. This made it a promising site.
And they found in Strat Unit 3, which is a layer that it looks like hay and sand mixed together. They did some testing and found that that hay is actually mastodon poop. They were hanging out on the edge of the sinkhole that had a spring in it, drinking water and, like passing the food that they did not digest very well at the edge of this pond. And in it, they found the bones of extinct camel and of mastodon and a bison and a few horse bones and some other bones and things like that. Some of the mastodon bones that they found were near fragments of what looked like flakes from making stone tools. And one of the things they found that was really exciting was a mastodon tusk that had marks on it in a place that would have been inside the mastodon skull when the mastodon was alive, right? And so they're like, this was evidence that people were butchering this mastodon.
Could people have coexisted with mastodons here in Florida, and with extinct horses and camelids and bison? If so, what was their Florida like? For answers, we don't need to go far from Page-Ladson.
I learned to scuba dive by dropping 30 feet deep into a place called Sloth Hole in the Osceola River, down in the inky black waters that you couldn't see anything, you could only feel on the bottom. And as I reached the bottom, was able to feel around, I could feel bones and teeth and all these wonderful things that fascinated me and has led me to be interested in understanding what the original ecology of Florida was prior to the present ecology.
The shelves behind me are essentially the results of, I would say, close to 40 years of intense excavations on multiple sites in the Osceola River and the nearby Wassissa.
When you walk into the Florida Natural History Museum, you're greeted by another elephant relative, a Columbian mammoth found in the Osceola River. Fossils found in the river tell the story of a landscape filled with food.
Consider what a protein bonanza might have been available to the first people that arrived here.
It would have been a landscape that would have been, if the archaeological data tell us anything, fairly attractive to the people living in North America for a lot of different reasons.
But the many large mammals here were more than food. They existed in a complex ecological web with each other and the plants around them.
This is a partial tooth of the Columbian mammoth that used to be here. And you'll see it's got a washboard effect. This would have eaten probably grasses and forbs. The upper jaw of a baby mastodon has what are called bunodont teeth. This is probably a grazer, and this was probably a browser, eating brush and woody stuff.
Where there are more forested habitats, there are typically more mastodons than mammoths. Where there seem to be more open habitats, then the situation's reversed.
Extinct grazers have modern relatives who allow us to somewhat envision the Pleistocene landscape.
The horses, the bison, mammoths, llamas, all of these grazers attest to the fact that there was a big grassland present in the late Pleistocene time.
What we know is that around the time that humans arrived in Florida, about 15,000 years ago, it would have been a pretty open environment with herbs and grasses and things like that, with some trees here and there.
Angelina Parati studies pollen found in sediments. Each grain identifies the genus of the plant that made it.
Pollen is comprised of one of the strongest biomolecules in the world called sporopollenin. And what's really useful is when we're able to get radiocarbon dates that go along with these pollen samples, and then also other changes like changes in animal communities or human population at the time.
Both fossils and the pollen record suggest that Florida was largely a grassland. We can get a feel for Ice Age Florida in one of modern Florida's dominant natural landscapes, the longleaf pine wiregrass ecosystem. Regular fire here kills back woody growth, making for an open, grassy understory.
Longleaf pine probably was here and was going back and forth between these states of being fewer pines, although still a pine fire environment, and a woody sort of environment that supported the browsers and the grazers.
At Lake Tulane in central Florida on the Lake Wales Ridge, it's really interesting because there's like these fluctuations between pine and oak ecosystems. And so these are millennial scale events where basically the ecosystem, the vegetation drastically changes. It's like kind of an oak savanna type environment. And then the next millennium, it's a total pine forest.
Page-Ladson contained the fossils of multiple grazing animals and 2 browsing mastodons. A pollen analysis of the mastodon layer indicated a cool, dry environment with few trees. Humans and animals would have been drawn to this water source. But how long ago? Dunbar and Webb's radiocarbon dates were eye-opening.
So they published the book, talked about the stratigraphy at the site, talked about these mastodons, talked about these cut marks that were on this tusk, and presented pictures of the stone tools that they had. All of those said they were dating around 14,400 or 500 years ago, right? A long time ago, and about 1,400 years older than the Clovis complex that I'd been telling you about.
They presented this evidence, but people just said, well, those artifacts, maybe they fell in while you weren't, paying attention. And so it just became forgotten.
They had a hard time convincing other archaeologists that an underwater site could be excavated scientifically. By the early 2000s, work on submerged prehistoric sites stopped until Jessie and her team restarted Page-Ladson in 2012.
It was a tough year. We got hit by a tropical storm right away.
First year was tough because a lot of hurricanes, flooding.
We were also working with old equipment that actually dated to the first Page-Ladson era. So it was these kind of unreliable engines and pumps and diving systems, and it seemed like something was breaking every day.
And so my first thing was figuring out how to clean out a carburetor on a motor that's been sitting for 10 years. They loaned me dredges, same thing, like nothing would start, nothing would run. I lost of my first couple of field seasons, I was 4 weeks each, and I would spend at least a week and a half trying to fix equipment and get it up and running and get holes patched in boats that had been sitting in backyards for 10 years.
We found no archaeological material really that year. A couple of flakes may have come up in the screen, but nothing really came from in situ in context.